Surds are mathematical expressions that contain irrational square roots, such as the square root of 2 or the square root of 3. These are numbers that cannot be written as exact fractions, because their decimal expansions go on forever without repeating. For example, while the square root of 4 is simply 2, the square root of 2 is an irrational number that cannot be simplified to a neat, whole value. Surds are left in their root form because it is more accurate and cleaner than using long decimals. Learning how to manipulate surds is an essential skill in algebra and involves a few key rules. There are 6 important rules to understand when working with surds. The first rule is that you can multiply surds together. For example, square root 2x square root 3 equals square root 6. This is useful when simplifying expressions involving surds, as it allows you to combine square roots into a single expression. The second rule is that you can divide surds. Just as with multiplication, when you divide 2 surds, you combine them under the same square root. For instance, square root 8 divided by square root 2 equals square root 4 equals 2. This rule helps when simplifying more complex expressions by reducing them to simpler forms. The third rule is that you can split a surd into 2 parts. For example, square root 18 can be rewritten as square root 9x square root 2, which simplifies to 3 square root 2 because the square root of 9 is 3. This is particularly helpful when you need to simplify surds that involve larger numbers. The fourth rule works in the opposite way. You can combine 2 separate square roots into one, as long as the numbers inside the square roots are being multiplied or divided. For instance, square root 5x square root 10 can be combined into square root 100 equals 10. The fifth rule is that you can add or subtract surds, but only if they are like surds. Like surds are those with the same number under the square root sign, such as 3 square root 2 and 5 square root 2. In this case, you can simply add or subtract the coefficients, the numbers in front of the surds, just as you would with algebraic terms. For example, 3 square root 2 plus 5 square root 2 equals 8 square root 2. However, surds with different values under the root, such as square root 2 and square root 3, cannot be added or subtracted directly. The sixth and final rule is rationalizing the denominator. If you have a fraction with a surd in the denominator, it is considered good practice to eliminate the surd. This is done by multiplying both the numerator and the denominator by the surd in the denominator. For example, if you have 1 square root 5 to the power of 1, you can multiply both the top and bottom by square root 5, giving square root 5. This leaves you with a simplified expression that no longer has a surd in the denominator. These rules are essential when simplifying expressions involving surds. For instance, if you were asked to simplify 2 square root 8 plus 3 square root 2, the first step would be to simplify square root 8 into 2 square root 2, giving you 2 square root 2, plus 3 square root 2 equals 4 square root 2 plus 3 square root 2 equals 7 square root 2. By applying the rules, you can simplify even complex surd expressions down to their simplest form. Manipulating surds is a process of applying these 6 rules in different combinations to break down or simplify expressions that involve irrational square roots. Whether you are multiplying, dividing, adding, or subtracting surds, or rationalizing the denominator, understanding these principles allows you to handle surd-based calculations with ease and accuracy.